So when I simplified and found a common denominator, my common denominator first of all from up here would be 4. So I multiplied top and bottom by 2 over 2, 4 over 4, 2 over 2, 2 over 2, and this one already had the common denominator. And so multiplying that out, I now have a common denominator of 4, and I can go ahead and factor out a 1/4 e to the 2x. When I factor out a 1/4 e to the 2x, this is what I'm left with, and of course plus c for my constant of integration. So the integral of x to the 4th e to the 2x dx is equal to this value. Make sure you keep that left-hand side going because we're going to need that in our next problem. So that is looking at the tabular method, and you can see that the tabular method can really save you some time. Okay, let's go ahead and look at a problem that is known as the recursive method. And some of these can take a long time, so you kind of have to stick with them. The recursive method will take 2 iterations of integration by parts. And what happens with the recursive method, I don't have an algebraic component that the derivative eventually will go to 0 on. So no algebraic component. And I should be careful there. Instead of saying algebraic, let's say polynomial. So there will be no polynomial factor whose derivative will eventually go to 0. Usually this is a mix of something like an e to the x and a trig. These are pretty common, but there's other ones as well that we'll come across in here. So, recursive method. Best way to explain this is to look at an example. And again, we're going to go through 2 iterations of integration by parts. Okay. So let's look at a real easy one. Let's do e to the 2x sine of 3x dx. Now you can use the tabular method with this too. It's just harder to kind of keep track of when you're going to jump ship. So with the recursive method, I usually just do it by hand, 2 full iterations of integration by parts. So to get started here, you choose a u and you choose a dv as we usually do. And it doesn't matter which one we pick. Our transcendental could go to the u, our transcendental could go to the dv, it just doesn't matter. I would, however, keep in mind that sometimes the e to the 2x's are easier to take a derivative of or integrate, so you might have one that you're better with, but it doesn't matter. We'll still get to the exact same conclusion in the end. I'm going to leave e to the 2x for my u, which leaves me with sine of 3x dx for my dv. And then remember, we take a derivative down to get du. The derivative of e to the 2x is 2e to the 2x dx. The derivative of e to the u is e to the u prime. And then we come over here and we integrate up. So this is saying, what is the integral of the sine of 3x dx? Well, that's 1/3 cosine, I'm kind of running out of room here, 1/3 cosine of 3x. Now, the derivative of cosine is a negative sine, so the integral of sine is going to be a negative cosine. So again, the integral of sine is our negative cosine component, and you integrate up. So to come up with our solution here, we need this left-hand side. The integral of e to the 2x sine of 3x dx is going to be equal to uv minus integral of v du. So let's go ahead and write it down. Negative 1/3 e to the 2x cosine of 3x, that's our uv, minus the integral of v du. The integral here is going to be a negative 2/3. The 1/3 is from here, the 2 is from down here, e to the 2x cosine of 3x dx. So uv minus integral v du. Okay. I'm going to rewrite, and again we need the left hand side here, it's going to be crucial. E to the 2x sine of 3x dx, copying everything along. Negative times negative is a positive 2/3 integral e to the 2x cosine of 3x dx. Now with the recursive method, what you're going to see here in a moment is when I go through one more iteration of integration by parts, this next phase is going to change this to a sine 3x, e to the 2x sine 3x. and then I'm going to be able to move it across and solve. The important thing here is to keep track of this 2/3 and use the correct signs. So I go through the same thing again. I choose a u and I choose a dv. Choose the same as you did last time, meaning last time I chose e to the 2x for my u. I want to keep this the same. I don't want to change it. Now, my dv was my trig function last time, so I want it to be my trig function this time too as well. If you swap these around, what's going to happen is you're going to get right back where we started. du is 2e to the 2x dx. You take derivative down, integrate up. The integral of cosine of 3x is going to be 1/3. The integral of cosine is sine 3x. So we write it all down again. And remember, the left-hand side is crucial to this process. So writing everything down, we have the integral of e to the 2x sine of 3x, negative 1/3 cosine of 3x. Now here it comes, 2/3. 2/3 has to go out front, and in this part that's about to follow, we want uv minus integral v du. So this parentheses has to distribute. That 2/3 out front of the parentheses has to distribute. So let's go ahead and write that one out. uv minus v du. So uv is going to look like 1/3 e to the 2x sine of 3x. uv minus integral of v du. I'm going to have 2/3 e to the 2x sine of 3x. Now we've almost got what we want here. What I need to do next is distribute that 2/3, and again I'm dragging everything else along here, and then I'm going to use algebra to solve this out. It's going to work really slick. Okay, so this is going to give me plus 2/9 e to the 2x sine of 3x. Okay, now this is going to be a minus. Here's our negative. 2/3 times 2/3 is 4/9. Okay, minus 4/9 integral e to the 2x sine of 3x. We still have not solved this integral. So what's going to happen is we're going to take this piece right here, and we're going to move it across the equal sign to combine with this like term. So it's just using algebra to solve. Okay, so what's that going to look like? When I move this across, I'm going to be adding 4/9 of these integrals to each side. And of course, in algebra, whatever you do to one side, you have to do to the other to balance that equation. So we could look at this as, there's one of these integrals. We could look at it as 9/9 if we wanted. And combining those, we end up with, okay, so when we look at this, we end up with 13/9 of these integrals, e to the 2x sine of 3x dx. And then on the right-hand side, we are left with all of these pieces right here. So that's what we're left with on the right-hand side. And remember, the plus c will tack on in the end. Now I'm not quite done, because I don't want to know what 13/9 of these integrals look like. I want to know what one of these looks like. So I need to solve for the integral by multiplying both sides through by 9/13. Of course, whatever you do to one side, you have to do to the other. These cancel by design. That's how we wanted this. And I'm left with what one of these integrals looks like. Integral of e to the 2x sine of 3x dx is equal to, I'm going to leave the 9/13 out front, and I'm also going to find a e to the 2x that's common to both of these and factor that out. I'm just trying to factor this as we go. And it looks like to me I'm left with a negative 1/3 cosine of 3x, okay, plus 2/9 sine of 3x. And I think we could find a common denominator from here as well. And again, dragging along that left-hand side was so important, because if I didn't have that left-hand side here, I couldn't have moved stuff across in order to solve for that interval. So it's very, very important that you keep that there. So I'm just going to keep dragging it along until we get our nice little solution here. And for this solution, after I find that common denominator, the common denominator would be 9. I'd have a negative 3 cosine of 3x plus 2 sine of 3x all over 9. And then, this is kind of slick, these 9's cancel. Okay, you can only cancel factors, so those are canceling out. And I'm left with the integral of e to the 2x sine of 3x dx is equal to 1/13 e to the 2x times, usually we like a leading coefficient, so I'm left with 2 sine of 3x minus 3 cosine of 3x. Now I can add on my plus c, my constant of integration. So there's my correct solution. I could check this, remember, by taking the derivative and simplifying the heck out of it, and once I take that derivative and simplify it, I should be able to get back to my original problem, which was quite a while ago. There it is, e to the 2x sine of 3x. So you can check this by taking a derivative, simplifying it a lot, and seeing if you get that integrand back. The recursive method, going through 2 iterations, is kind of long, but it's pretty rewarding in the end when we get that correct solution. We're going to spend a couple days on the homework for this. So again, the problems take a long time, they take a lot of paper, and I realize that, so we're going to spend 2 days on this in class. Thank you.